some time on combining two skills we already have. So today shouldn't feel like a completely new skill, but we're going to combine what we learned yesterday with solving equations from last test. It was still chapter 5. Do y'all remember the types of equations we could solve? We had exponential, a logarithm equals a logarithm, and a logarithm equals a number. Well, today we're going to focus on logarithm equals logarithm and logarithm equals number. Break out some English. Logarithm, singular or plural? Singular, right? There's only one of them. So if I am going to solve using that process, I need one logarithm on one side. Everyone agree with that? So what does that mean I'm going to need to do on these problems to be able to use one of those scenarios? Combine them. So you can kind of see why, for solving purposes, we learned what we learned yesterday. So on this first one, what do I need to do very first before I can combine anything? On the left. I wouldn't want to, because then I couldn't put it with the 4. I would like to combine these two logarithms, like we did yesterday. What would I need to do first? Before that, take care of the 2. Right, I can't combine if there's a 2 in front, which you may have been doing that in your head. And so then, in which case the answer is yes. So we have log base 6 of x squared. So that's how you, if you're combining, that's how you deal with a number in front. This might help you with last night's homework as well, since we're not turning it in yet. Since we're going to take it up tomorrow, you can use that. And then what about here? Multiply. So log base 6 of 2x cubed. Does everyone agree with that? Now, this fits one of my categories. It fits a logarithm equals a number. How do you solve an equation that is a logarithm equals a number? You have a note card for that. How do you solve a logarithm equals a number? Rewrite it as an exponential. Do the circle thing. Everyone agree? So I get 6 to the 4th power equals 2x cubed. Someone with a calculator, what is 6 to the 4th power? And then how would I get x by itself? Divide by 2. Whoops, can't do that. That's a nice try. Divide by 2, and what is 648? And the cube root of 648, I would have to think. Let's see, we have, she's probably going to get there before I do. Does it have a perfect cube root? No. So the cube root of 648. Okay. You could break it down for today, since that's not what I'm teaching today. I'm just going to leave it as the cube root of 648. If you did want to break it down, you'd have to use a factor tree. You'll know what I'm talking about. Okay, so let's look at the next one. What would I need to do first to make it fit one of my scenarios? Combine the logarithms on the left. So I get log base 5 of x times x plus 1. I'm going to write that as x squared plus x. Is that okay with everyone?
Yeah.
Now I have a logarithm. Log base 5 equals another log base 5. What do I do there? I have a logarithm equals a logarithm. You have a note card. Look at it real quick. Logarithm equals a logarithm. What do I do? Ignore the logarithms. It's not quite dividing them out, but kind of looks like it. They just go away. Because would you agree if log base 5 of x squared plus x equals log base 5 of 20, then x squared plus x would have to equal 20? Right? That makes perfect sense. We even talked about that yesterday with that property of logarithms. So x squared plus x equals 20. How do you solve quadratic equations? Ones with squares in them. If it's only x squared, then yes. Any other one, though? Solving quadratics. You probably have a note card for that, too. Get 0 on one side and factor. If it doesn't factor, you have to use the quadratic formula. Luckily, this one does. Factors of 20 that subtract to give you 1. Good. And it's positive 5 and negative 4 to get the positive x. So it's been a while since we factored. How are we doing with that? Second. X equals negative 5 and 4. What do you know about logarithms? You can't put a negative in a logarithm. So check. Does negative 5 make either one of those logarithms negative? Yes. So not negative 5. Does 4 make either one of the logarithms negative? No, so it's good. Any questions about that one? This one's almost identical to the last one we just did, so I'm going to look at this next one here. What do I need to do before I start? Combine the two logarithms on the right, or you could move one of them to the left and then combine them on the left. It doesn't make any difference. How do you combine them if there's subtraction in between? Division. Which case does this fall into? There's two cases of logarithmic equations. There's a logarithm equals a logarithm and a logarithm equals a number. Which one is this? Logarithm, logarithm. And when I have logarithm, logarithm, I ignore the logarithms. When I have logarithm number, what do? Rewrite. So you either rewrite or ignore the logarithms. So I have x plus 5 equals x minus 1 over x plus 1. We don't like fractions, right? Last time I checked, you didn't like fractions. So I'm going to multiply both sides of the equation by x plus 1, or cross multiply. How y'all prefer cross multiply? Okay, so let's cross multiply. That's over 1. Everyone see what we're doing there? So that we don't have a fraction. How do you multiply x plus 5 times x plus 1? How do you do that? Oh, we're kind of out of it today. How do you multiply x plus 5 times x plus 1? Gotta distribute it. Use FOIL if that's the word you like to use. If you had Miss Lowe and just can't bring yourself to do it, then just distribute. X squared plus 5x plus 1x plus 5 equals x minus 1. What do I do from there? Good. Add 1 and subtract x, and you don't have to do that at the same time, but you need everything on one side. You need 0 on one side because it's a quadratic. You're going to have to try to factor. 6 minus 1 is 5x and plus 6. What are the factors of 6 that add to give you 5? 3 and 2. How many of you would have wanted to pick 6 and 1? Why can't I not pick 6 and 1? Good, they're both positive. It's addition, so I can't do 6 and 1. 1 would have to be negative to do that. So -2 and -3, what do I do with both of those? Plug them in, see if they make anything negative. Do they? If I plug in -2, do I get a negative in the logarithm? If I plug in -3, do I get a negative in the logarithm? What does that mean? Neither one of them work, so this is a no solution. If you were to graph this and solve this graphically, they wouldn't cross, they wouldn't intersect. I think one more example will get us to where we need to be, and then we can do the other 2 examples as a bell ringer tomorrow.
So, you just said that you could put it in the calculator and they wouldn't intersect. Would you be able to do that without work?
Yes. Yes. So these are still equation solving. So you could still do, now you would have to put the complete original in the calculator, but yes. We are learning how to solve them by hand, but as you know, we're not going to forget that we have calculators and they exist, and we're going to check, and we're going to do all kinds of... Again, our goal is not to eliminate the calculator, and it's not to eliminate by hand. It's to give us both options for when one fails us. Have you ever been on the calculator where you can't get the window to set? Me too. I mean, I've even been on, and I'm pretty good at calculators, and I still sometimes will get there and and I may miss an intersection in the calculator. So what you want, the ideal scenario is that you could do it both ways. So, okay, one of these 2. What's weird about both of these? This one has a 2 plus a logarithm, and this one has a 3 plus a logarithm. Is there any way you can combine a number with a logarithm? No. That's a problem, isn't it? Because these don't fit any case. Neither one of these fit either one of my cases. Right? So what do I need to do? I love that. Who said that? Was that Hunter? It's in that vicinity. Move the logarithm. I need to get it to where all the logarithms are on the same side so that I can combine them and get them to be a logarithm equals a number. I've got to make it fit either a logarithm equals a logarithm or a logarithm equals a number. If there is a number anywhere sitting by itself in the problem, I have to make this a logarithm equals a number problem. Does that make sense? Nate, you good? Okay, so I've got to make it a logarithm equals a number. So on this one, I'm going to subtract log base 7 of x. So I have log base 7 of x plus 5 minus log base 7 of x equals 2. How do you subtract logarithms? One of the most common errors here is for you to say that this is 5 equals 2 or something crazy like that because you subtract x's. Do we subtract when we're subtracting logarithms? What do you do? Divide. Log base 7 of x plus 5 divided by x. And which type of equation does this fall in? A logarithm equals a number. And how do you solve a logarithm equals a number? Rewrite it. So I get 7 squared equals x plus 5 over x. So 49 equals x plus 5 over x. And again, we don't like fractions. So what are we going to do with that? Cross multiply it. So I get 49x equals x plus 5. How do you solve that? Good. Subtract the x from both sides. So I have 48x equals 5. And so x is, 5 over 48. Go back up and look. Does that make either one of those logarithms negative? No. So it is a good answer. Checked it is a good answer. Okay, what we're going to do today is we're going to do a cooperative activity. You're going to get in pairs. If you don't have a pair sitting next to you, we'll move you around. If you're in a group of 3, I'm going to try to get you in pairs. If it doesn't work, we'll work with a group of 3, but only one group of 3, and only if we must. So we're going to work in pairs, and it has you do a step and your partner do a step, and I want you to talk about it. Don't just go through where y'all are working and not talking. I want you to do a step. They're going to do a step. Talk about it. Make sure you agree that that's how to do it. We're going to spend 2 days on this because it's something people will struggle with, being able to solve these by hand. So that's going to be your first assignment, is a pair activity. The second assignment you have is a book page. Let me write that down for you. It is page 350. Numbers 23 through 40 all. Both of these are due on, not tomorrow. What's tomorrow, Thursday? Friday. Both of these are due Friday. Both the cooperative activity and this book page. So that gives you today, the rest of today in class, and a good portion of tomorrow in class to work on the cooperative activity. Someone be in charge of remembering that we didn't do 3 and 6 on this notes page, and tomorrow with everyone here, I'll go back and do numbers 3 and 6 so you can see one more example from work from me. But then you've also got the cooperative activity where you're learning, and then the book page is your time to see if you can do it all by yourself. You can, 23 through 40 is quite a few problems. So I would do some tonight, but then you do have all day in class tomorrow and tomorrow night. So you don't have to try to do all of those problems tonight. Okay, any questions? Do that.